g of x. Very good. Good. Remember, I have to replace this. So I have f of. Very good. Now I look at f. F says whatever has to have the square root on it. So what would be the final form? Of 5x squared plus 3. Do we get h of x? So the inner and the outer are fine. We obtained that. Okay, one thing I would like to look at here, let's say problem 94 on 311. So we're asked to find g comp f of -1. We're not given g, we're not given f. We're given their graphs. I'll show you the graphs in a minute, but please tell me, what does this mean? What is the definition of this? How do I write it? How will I explain it to anyone? Very good. Where is the starting point? And which one is the inner function? Where is my first step for sure? Which one? Of course, right here. That's why I always deleted it, so you remember I have to start from. So I have to find f of -1. So I'm looking at the graph now. Here it is. So f is in blue, g is in red. I want to find f of -1. Can anyone give us, this is f and this is g. Can anyone give us f of -1? 1. When x is -1, it crosses the function right here. So I read 1. So then I replace this by one more time by what? Awesome. So now I have to find g of 1. I go back to the graph. I look at the purple graph, and I want to find g of 1. Can anyone tell us what is g of 1? -5. Very good. Awesome. So we can create the function composition, or if you want to evaluate the function composition, even if we don't have the function, but we are given the graphs. But we have to do it in sequence. So I have to write the definition. I have to start from the inside, from the inner function. I get the number, and then I plug in the outer function. Any questions on this? Any questions? Okay. Yes? Good. So 2.7. I don't want to put the title just yet because you will give me the title in a minute. Any questions? Damon, any questions? It was g of f of -1.
I was looking at number 92. I thought you wanted another question.
Oh. Oh, you wanted to look at another one? Okay, so let's take a look. So what was the question? You're looking at 92?
Yeah, F of G.
Okay, so you have to find g of 1 first. How much is g of 1?
It is going to be 3 or -5.
-5. You're looking at the purple one. And then you have to find f of -5. How much is f of -5? You have to look at the blue now.
That is 3.
Awesome. Perfect. When we looked at functions, some time ago when we started chapter 2, we looked at 3 different situations. Situation 1, you can put any numbers you want. It's not important. Any number here, and so on and so forth. Good. Situation 1. Can anyone say anything about it? Is situation 1 a function?
Yes.
Yes, it is a function because each x corresponds to only 1. Good. Here's a question for you now. We did mention this when we talked about it, but I said don't worry about it just yet because we're going to talk about it now. So my question is here, if I want to go backwards, if I want to create a function this way, to each x there is only one y, to each x there is only one y, to each x there is only one y. Can I create a function? Yes. So that's why this is called one-to-one. One-to-one function, meaning even to each y there is only one x. Not only each x corresponds to only one y, but also each y corresponds to only one x. And I can create a function going backwards. What about this? Oh no, this is a function. To each x there is only one y. To each x there is only one y. To each x there is only one y. So this is definitely a function. My question now, if I want to go backwards, can I create a function? No, which means this function is or is not one-to-one, meaning to each y there is only one x. Not one-to-one. What about this? That's true. So we don't even need to talk about it. This is a relation, it's not a function. It's not important right now. Perfect. Okay. So what do you think I'm trying to talk about here? Because I'm asking you, let's write a note. Only, and then you'll give me the title. Only one-to-one functions have functions. And that is the title of this section. Only one-to-one functions have, what is the word I'm missing here? I'm showing this. That's true. Say it again. Thank you. Inverse functions. So that's the title. Inverse functions. Indeed. Only one-to-one functions have inverse functions. So let's think about this. If a function brings 2, is applied to 2 and returns 3, what is the ordered pair for the function? 2 returns 3. What is the ordered pair for this function? 2, 3. Good. What would the inverse function have as an ordered pair? It will be applied to 3. It will return 2. Why? Because the function is one-to-one. So if a function has the ordered pair 2, 3, the inverse function, and this is the time I want to mention the notation. This is the notation. Will have the ordered pair 3, 2. So notation, f inverse. So this is not f raised to -1. It's not 1 over f. So this is the notation f inverse, which means the function that is the inverse function of f. Any questions? So one more time, if the function has the ordered pair 2, 3, the inverse function has to have the ordered pair 3, 2. Okay. Any questions so far? I want to give you a couple of graphs because I would like to identify one-to-one functions from a couple of graphs. Here is one graph. Here's the second graph. And here's the third. We don't know this function. We'll come back to it in a moment, but we do know this one. What function is this? Linear. We also know this function. What type of function is this? Quadratic. This one we don't know. We will study it in chapter 3. So let's start with these two. Remember, are these all functions, by the way? By the vertical line test, all of them are functions. Perfect. Now I want to find or establish whether this one is one-to-one. Remember the idea. To each y, there is only one x. By the horizontal line test, for this y value, I do read only one x value. For this y value, I do read only one x value. Is this function one-to-one? Yes, it is one-to-one. Will it have an inverse function? Awesome. Good. What do you say about this? So I'm going to write this here. By the horizontal line test. What about this one? Is this one-to-one? No. By the horizontal line test for this y, I don't know, y equals 2, I read x equals 2 and I read x equals -4. Is the quadratic function one-to-one? No. What about this function that we are going to talk about later? No. By the horizontal line test, look what happens here. For a particular y value, there are 3 different x values. So not one-to-one, not one-to-one. Very good. Please give me a linear function. Anything that you can think of. Awesome, awesome. This is really strange. Really strange. As you know, I have another class. Amazing. Another class, and I said the same thing. Look at the function they picked. And I know you were not here when this happened, so okay, wonderful. So there must be something with this. Good. Is this function linear? Yep. Is this function one-to-one? Remember the graph.
It's linear, yeah.
It's linear, so it's one-to-one. We just talked about it, right? All linear functions are one-to-one. Perfect. Good. So find f inverse. 4-step procedure. Step number 1. Replace f of x by y. And you should say, wait a minute, let me think. Am I allowed to do that? And I'm asking you, am I allowed to replace f of x by y? Because they are the same. Okay, perfect. So that's allowed. Step number 2, interchange x and y. Now let's stop again. Am I allowed to do that? And allow me to show you something before you answer. As I gave the example a few minutes ago, I apply f to 2, and let's say I get 3. Now, this will be the inverse function that I apply to 3 to read that will return 2, correct? What does 2 represent for f? It's x, right? What does 3 represent for f? No, it cannot be x. Why? What does 3 represent for f inverse?
X.
Exactly. That's the reason why I'm allowed to interchange x with y when I find f inverse. Because now this value that was initially y, it will become x for f inverse. So I'm going to replace this by x. I'm going to replace this by y, 2y plus 3. In step 3, I want to solve 4, and you tell me what am I after now? Exactly. Because y is f inverse now. Awesome. So please tell me how to solve this equation for y. What will I have to do first?
Take 3, subtract 2
Yes.
both sides.
X minus 3 equals 2y.
5, 2.
Yes. So x minus 3 divided by 2. Final step, replace y by, what am I after?
3.
Replace f inverse x minus 3 over 2. Very good. Now I would like to graph both the function and its inverse on the same coordinate system. Any questions so far? Okay, so I'm just going to copy them here so I can put that page away. 2x plus 3 and f inverse x minus 3 over 2. Okay, perfect. So since it's linear, I'm going to find the x and y intercepts. When x is 0, how much is y? What is the ordered pair that you and we just determined? I said y equal to 0. I have to move 3. Negative 3 equals 2x. How much is x? Very good. Negative 1.5. What is the ordered pair that we just determined as the x-intercept? Negative 1.5, 0. Negative 1.5, 0. Perfect. Ready? I need a bigger graph, so because I want to make a point. Good. So the first ordered pair is 0, 3. And the second ordered pair is negative 1.50. I connect and extend the line. This is f of x, 2x plus 3. Any questions on this so far? So we determined the x and y intercepts, and we plotted those two, and I graphed the line and extended it. Without any effort, I would like you to give me 2 ordered pairs that I will plot to graph the inverse. No calculations required. Say it again. 0, negative 1.5. Very good. So right here, 0, negative 1.5, and f inverse x minus 3 over 2. I didn't have to find any x and y intercepts because I had them. I just had to reverse them. And I just want you to remind us, and I'll explain in a moment what happens here. What line is this? The line that bisects the first quadrant and the third quadrant is the first function we had on the list of functions for transformations. Here's what happens. Can anyone explain this? What's happening here with the graph of f and f inverse? I'm going to write a note and you'll put the word I'm missing. This happens always. The graphs of f of x and its inverse are with respect to the line y equals x. Very good. Yes, that's why I folded, so you can see that this one overlaps here and this one overlaps here. And why is that? Look here. This piece, the distance between this point and the line, y equals x, must equal this piece. And then the same thing here. This piece must equal this piece. And so on and so forth. Why is this here? Because this point is, for example, I'm making this up. It's not that point. -5, -5. And if I reverse -5, -5, it must be a point on both. Because -5, -5 and -5, -5 is the point for f inverse. So it has to be the same point. So this is always the case. The graphs of f and f inverse are always symmetric with respect to. Okay, I would like to determine one more, because you will find this in my math lab. Determine one more inverse function. Let's say 28 or 26 on page 321. We are given f of x, which is x plus 5 over x minus 6. We are told we are going to study this function in chapter 3. We are told it's 1-to-1. We are told find f inverse. Can anyone walk us through the process? The previous case was much easier because it was what type of function? This is more difficult because it's what type of function? Does it have x squared? No. So it cannot be quadratic. Say it again. No, it doesn't have a radical. Very good. Say it louder. Yes, or rational. When it has a fraction, it's rational. A polynomial divided by another polynomial. Good. Step number 1. Step number 1. Yes, yes. Y equals x plus 5 over x minus 6. Perfect. Step number 2. Swap first. Yes. X equals y plus 5 over y minus 6. In step 3, what am I solving for? I solve for y. Good. So here's your hint. How do I solve this equation for y? It's a proportion. There is no need for least common denominator in a proportion. What do we do in a proportion? You forgot chapter 1. Yes, yes. So xy, x times 6 equals y plus 5. How do I solve for y? Say it again. I'm focusing on y. It's not a mistake, but I'm focusing on y. My target is y, and then I'll get rid of the rest. But y is my first thought. I cannot divide by the variable I solve for. Very important. Please note, do not divide by the variable we solve for. I'm solving for y. What will be the next step? Say it again.
X into
Subtract 5.
The target is y.
the first equation.
Yes?
You factor y out.
I cannot factor something that is on one side with something that is on the other. Not yet. You are on the right track, but I have another step to put in there. What will be that step? Yes, but not all of them. Only what I need. What do I need to have on one side? Yes. So I have xy. I have to bring the other y, exactly, minus y, and I have to bring 6x to the other. Of course, when I solve for y, I have to have all terms with y on one side and the terms with no y to the other. Perfect. Now, yes, you can suggest. You're right. Say it again.
You factor
Yes, what am I factoring out?
as y.
Yes, what is left?
X minus
Perfect. So finally y is, and now I can divide. And I'm not dividing by y, I'm dividing by the quantity that multiplies y. So this is 6x plus 5 over.
x minus 1.
Final step, f inverse of x is,
X 6x.
and I have to write that x does not equal 1. We did this in rational expressions and rational equations.
I have a question.
Yes, please.
Your first equation, x can't equal 6. So how does that work in the inverse?
Very good. Awesome. You will see in section 3.6. Very good. So I'm just going to give you a simple example now. So let's say I have f of x equals 1 over x minus 1. You can relax for a minute. This is not part of this chapter right now, but I have to answer. So you will see when we get the chance to graph this function, you will have a vertical asymptote at x equals 1. So close your ears. You don't need to know this right now. So when I graph this, 1.1, so it'll be positive. Okay, so the graph will look like this. We don't know this yet, so as I said, close your ears for a moment and your eyes. So this is 1 over x minus 1. When I find the inverse for this, I have y equals 1 over x minus 1, and then x equals y minus 1, and then xy minus x equals 1, or xy equals x plus 1, so y will be x plus 1 over x. So this function will be undefined at 0, right? And because this function does not have 0 in the range. So when we graph this, it will still be symmetric with respect to y equals x, and it will have a vertical asymptote at 0. So it will be 1 plus 1 over x. So everything will work out fine. But your question basically was, this function is undefined at 6, and this function is undefined at 1. For that reason.
I see that.
Because this function is undefined at 1, but its range, it doesn't exist at 0. So that's why this is going to happen the opposite. So this function will not exist at 0. Where the range, where the value does not exist in the range. Yeah, very good question, actually. Good. Let's say I create a function. You have in your pocket X dollars. I don't know what it is. I don't care. You have X. And I come in and I say, I want to give you $5. And then I think for a minute and I say, you know what? Give me my $5 back. What happened to your X? By me giving you 5 and taking it away from you a minute later, what happened to your X? The answer is nothing. right? Nothing happened to x. Which functions did I create? I created two functions. One in which I was giving you 5, and then later on I said, okay, you know what? Whatever you have, I'm taking 5 back.
You got g of x is the x, whatever you had in your pocket.
But remember, there are two procedures. Here's 5, I'm taking it back. Exactly. Do you think that these two functions are inverses of each other? So you have x in your pocket, I'm giving you 5, and then 5 minutes later I'm taking it away.
Yeah.
They are inverses of each other. So what do you think the answer is if you decide to calculate this and decide to calculate this? What do you think fits in there? Remember, you have x. I'm giving you 5, so now you have x plus 5. But then I'm taking it away because I'm applying the second function now. Whatever you have, I'm subtracting 5 from it.
You started with x.
Exactly. Nothing happened to x. This is what it's called, the property of, what do you think? Exactly. That's why I said they must be inverses of each other. Because nothing happened to your x. Although we applied two functions. In one in which I was giving you 5, and the second function I applied by taking 5 away from what you had. So this is the property of inverse functions. Let's check. We claim that these two are inverses of each other. I have to determine this. I have to determine this. And what should the answer be in both cases for us to conclude they are inverses of each other? So when I determine f cum g, what should the answer be? And when I determine g cum f, what should the answer be? And if both of them are plain x, not x squared, not x plus 5, not x over 3, nothing, just plain x, what do I conclude about f and g then? They must be inverses of each other. Okay, by definition, f cum g. I know I have 4 more minutes left. Definition. Awesome. F. F, what does F say? Blah plus 5, but this is my blah now. So it's blah plus 5. It's x. Let's do the other one. If one of them is x, the other one will be x as well. So g of f of x. So now I have g of f of x, which is x plus 5. Now I look at g. G says blah minus 5. But this is my blah now. X plus 5 minus 5. What is the answer? So what do you say about f and g? Must be inverses of each other. Because of this. Must be inverses of each other. Which means they cancel their effect on x. One, the subtraction cancels the addition. The addition will cancel the subtraction. They annul themselves, their action on x. Nothing happened to x. Okay. Let's just look last example, number 6. If I can finish it in 2 minutes, then I'll stop. F of x equals 3x minus 7, and g of x equals x plus 3 over 7. The question is, are these inverses of each other? What do I have to show or determine? Bless you. What do I have to show or what do I have to determine? The function composition. Yes. So I have to find, let's say, g cum f of x. And what should the answer be? X. If it's not x, Do I have to determine the other one?
No.
No, there is no need. Good. So g of f of x, which is g of,
3x minus 6.
good. So now I'm looking at g. G says blah plus 3 over 7. Oops, I'm sorry, I didn't mean to write this. Yes, there is no need for parentheses. It's just this at the top. Plus 3 divided by 7. So I have 3x minus 4 over 7. Does this equal x? No. What do you conclude about the given functions f and g? Not inverses of each other. Not inverses of each other. I know this is a 13-week class. I know it's a lot